Assalamu alaikum. In this lab I'll be explaining some assembly language code. So first example we have in which we are running a loop which is adding 3 10 times. So basically we are so in this code first we can see we have given register 16 a value of 10, which will basically keep the count of the loop, that how many times it runs. So we'll be running it 10 times, so that's why we have given it stored the value 10 in it. Then in the second line we are uh, giving the register 20 the value 0, which will be the starting value. And to add 3 every time we are giving register 21 the value 3. Now we have created a label again here, and we will perform addition, in which we are adding 3 to R20 register 20, and we will be giving a decrement to register 16, which has our counter value, which is 10. And then we will use the brne branch not equals to command, which will take us back to again until the register 16 value becomes 0. So in this way the loop will keep uh, continue until it becomes until the register 16 becomes 0. So now let's debug it. So here we can see there are registers here, and initially a register, we can see that on the first line, if I go to step into, we can see our register 16 has the value 10. And now one more step further, we can see that our register 20 has a value 0 here. And a step further, we can see our register 21 has a value 3 here, as per the first 3 commands. Now as we move further, we will notice that R20 has now value of 3, which means it has incremented one time the loop has occurred, and its value has an addition has taken place, and the value stored, which was previously 0 in R20, has now become 3. Going one step further, we will see that value of R20 is incrementing. Now it is incremented to 6, and now then 9, and 12, and now 15. So similarly we will continue incrementing, and we can see here 1 5, which 1 8 in hex, 1e, and so now we can see here R20 has the value hexa 18. Going another step further, now 1b and 1e, and now 10 times the loop has completed, and its value has again became 0. So this is how our first code is working, how our loop works. So now as we have seen how this loop works, so from this working we can make a deduction that as we know that our counter is working when we have stored a number, that how many times we have to continue the loop. So at how many times we want to run the loop, so for that we have to store a counter value in a register, and we know that register is an 8-bit register, so values till 255 can be stored, which means that we have a limitation on the number of times the loop can run. So we can only run a loop 255 times using a single register. So so now if you want to run a loop more than 255 times, so what can we do? So for that we will see in the next example that we can use nested loops to run loops more than for the number more than 255 times. So now this is another example in which we'll be running the code more than 255 times, which is 700 times, and in this we'll be using nested for loops, nested loops. So first of all we have LDI command, which is storing value hexadecimal value 55 in the 16 register. We will be in this code, we will be complementing the value of register 16 700 times, so using the nested loop. So here we have another register 20 which has a value of 1010, which is basically a counter number, and we have another LDI command which loads register 21 with the counter number 70. So basically the register 20 has the counter variable for the outer loop, and the register 21 has the counter variable for counter number for the inner loop, and we have labeled both the loops. Then there's the complement command and the decrement command for the inner loop first, and which is in store, which whose counter number is stored in the register 21, and then the brne command for the loop 2, and for the inner loop, and then again the decrement command for the outer loop, which is for the in the register whose counter number is in the register 20, and then the brne command for the outer loop, which is loop 1. Now let's run this. Here we can see in the register 16 we have the value 0x55, which is the 55 hexadecimal, and we will see that how complement of this value will be taken. Here we can see register 16 has changed to the value AA, and this will continue to happen. The complement will continuously be taken, and this will continue to for 700 times. As we can see, as you can see how many times the value is being complementing and changing. So now this is the last example in which we'll be looking at the if condition. So first of all, we have given a variable mylog an address which is 0x200, and then the next command we are giving mylog the register, assigning register 30 to, in the register 30 we are assigning the address of the my location, which is 0x200, and then using the test command we are testing it for r equals is the value equals to the 0, which means the 0 flag of the register is 1 or not. So if the register flag is 1, which means there is 0 in this 0 stored in this register. So what will happen in the next command, we see that brne, which means that if it is not true, which means if the register has a value register's value is not 0, it will move towards the next, which is here, which is at the end of the code. And if this condition is false, the code will continue and register 30 will get the value of 55. By this command here we can see register 30 has assigned the value hexadecimal value 55, and this will be stored in my location 2. So now let's debug this. So first of all, here we can see that register 30 here has a value of 0 0, and as we move further in the code, we test that test condition has been tested that r30 is 0, so it will continue. The brne command will not execute, and it will not to move. It will execute, but it will not skip the last two. So now we have reached. So now in next command we can see that now our r30 has got the value hexadecimal value 55, as our brne command didn't skip these two commands. It didn't make the code to jump to the next label, and if we continue to run it, we will see that again we reach the top of the code. Again the condition is tested, and at this time the result is the complete opposite. That is that the condition tests that the 0 flag is 0 now, which means that r30 has a value of 55 hexadecimal value. So now which means that the brani command will be executed, and the code will jump to the next label here, and these the LDI and the STS command below it won't execute. So we can see that the code has again restarted, and the value of register 30 hasn't changed, and this will keep continue happening.